So here is a typical Leaving Cert question that we see, and it's actually from the Leaving Cert in 2019, and it's part B, and it works on what we've learned already. So how can you use the skills you've learned to answer a Leaving Cert question? Well, it gives us our Leaving Cert question. This time they've decided to use v as their complex number here. So saying v is equal to 2 minus 2 root 3i. But you need to write v in this form here, which we now know is polar form. So where r, which is the modulus here, must be a real number of some sort, and theta, the angle, must be between 0 and 2 pi. So I've drawn an Argand diagram of the situation here. So we can see that it goes out, v has a real component of 2, and it has an imaginary component of minus 2 root 3, so it goes down the imaginary axis here. So here we are here at v. So what do we need to get? Well, we need to get the modulus first. That's the length of this green line. Now, making a right angle triangle, yeah, this will be the hypotenuse, where one of the lengths will be 2 root 3 and one of the lengths will be 2. So essentially for this, it's as simple as just the square root of 2 squared plus minus 2 root 3. So minus 2 root 3 to be squared. Oop. Now, so let's do that there. So, well, we know 2 squared is 4, and minus 2 root 3 squared, that's the minus 2 is squared to be 4, the root 3 squared ends up being 3, so 4 times 3 is 12. So that gives us a plus because it brings it positive 12. So you can actually just, if you put it into your calculator exactly the way I've written it in there using brackets, you should get square root of 16, and we know the square root of 16 to be 4. Now the angle. So here's really the important part, right? So what is the angle? You might remember or seen previous videos to see that the angle is made with the positive real axis, and we must go in this anti-clockwise direction, otherwise we're going negative. So we'll go from here, we go all the way around, all the way around, all the way around to here. So this is actually the angle we want. How can we get it? Well, there's two ways of getting it. We can either come all the way around to 3/4 of full. Now what's 3/4 of the full way? To here, and add in whatever angle is here then. So remember, 180 degrees is pi. So this is like pi and a half, because it's, and that would be 360 degrees, which would be 2 pi. So that's like 1 pi, another half a pi, which is 90 degrees to here. So that's like 1.5 pi to here. So that's like 3 pi over 2, or 3 over 2 pi, same thing. So we can take 3 pi over 2 and add in this little angle here. Or what I like to do is actually take the 2 pi and subtract this angle from it. So 2 pi, of course, minus this angle here will bring us back to where we want to be, right? So let's do it that way. Let's actually find what this angle is here, and let's use our knowledge of our trigonometric ratios. So let's draw this little line. We'll put a line down here, and we'll say, okay, so this angle, the opposite side will be what? So I'll put them in green, so they're lengths. I don't care about the negative sign here because it's a length. So this length of this dotted line here will be 2 root 3, and of course the length here will be 2. Now I have the opposite side. So remember your trig ratios. I have my opposite side and I have my adjacent side here. Okay, so opposite and adjacent, that's going to be tan ratio. So therefore I remember that tan inverse of opposite over adjacent is going to be what I'm looking for. Again, you wouldn't write this in the exam, of course, you just go straight to the answer. So what is that? So the tan inverse of, so the opposite side to that, well, the opposite side to theta is 2 root 3. And then the adjacent side is 2. Okay, so essentially that's the tan inverse of root 3, because the 2's will like cancel there if you like, right? So what's the tan inverse of root 3? So if you want to go to your logbook special angles table on page 13, you'll find these pretty quickly. So the tan inverse of root 3 is actually going to be 60 degrees. Now for us, what's 60 degrees? Remember, 180 degrees is pi. 60 degrees is a third of 180. So that's a third of pi. So the tan inverse in radians, you should get pi over 3. That's not our answer now, remember. That is the angle in here, is pi over 3. Okay? So if this angle is pi over 3, the angle we're actually looking for is going to be 2 pi, and then back a pi over 3. So 2 pi minus a third of pi. So that's like 1 and 2/3 of pi. How do you write 1 and 2/3 as a fraction? That's 5 over 3. So the argument for us actually is 1 and 2/3 are 5 over 3 pi. 5 pi over 3, of course, same thing. So I have my modulus, which was 4. I have my argument, which is 5 over 3 pi. So therefore, v in polar form is equal to modulus, which is r here, which is going to be 4, cos of the angle. Remember, it's now 5 pi over 3 plus I sine 5 pi over 3. And that's it. Now, it's the second part of the question. The first part's got to do with finding roots. But there you go. It's actually pretty straightforward once you have the tools that you need to do it, which is both finding modulus and that. So the hardest thing I'd say maybe for you to figure out, to comprehend, is actually how to figure out the angle using the method we talked about, going to positive real axis. So you can either go to 1.5 pi plus this angle here, but we went all the way to 2 pi and we brought it back a bit here, whatever the angle was. And that's it.